climate change is very much having an impact on the agricultural industries. That's a past tense discussion. So what I've got here is probably the first third is giving you some insights into what has already happened, because our group used to spend time predicting what may happen. We've now spent a bit of time saying what has already happened, what's the underlying impact of climate change. So I'll give you a few insights into a few industries. We were told not to have too much data, so the first bit has a little bit of data, and then I'm going to tell you more of a narrative for the second half. And the narrative in the second half is more around what's changing in various industries, where's the drive coming from for change, and what do we see subnational jurisdictions, what do we see companies doing in responding to this climate challenge, and what impact that might have on the agricultural industries. So let's start off. I've got a bit of a mind map here, if you can see that. So the areas that I have been involved in climate change has been both the mitigation and the adaptation space. We've done a whole lot of work in enteric methane and nitrous oxide. I won't present any of this work just because there's not enough time. And I thought what I'd do is I'd weave a story through adaptation, a little bit on sequestration, something on the impacts that agriculture is already experiencing of climate change, but then spend most of the time down here in what do we see happening in industry, what do we see happening in subnational jurisdictions. Not a lot happening in government, as you're probably well aware. So let's start with that. We know that temperatures are increasing. We've seen 2019 as the hottest year that the planet has experienced, and that's a global map of where temperatures have been recorded as the warmest on record, much warmer than average, and there's very few spots in the globe left where temperatures are not much warmer than average. We've also seen average temperatures continue to increase. You see this temperature anomaly graph just increasing, which correlates with the increasing frequency of extreme climate events. In fact, we've even started to have discussion around, well, do we actually redefine what we mean by an extreme heat event, because the norm keeps increasing. And we now know that the global average temperature is 1.1 degrees, officially 1.1 degrees as of 2019, above pre-industrial levels. So that's quite a shift. If the Paris Agreement is telling us we want to try and keep the globe to below 1.5 degrees, the trajectory we're on says unless something dramatic changes, 1.5 is not possible, unless something big changes, as I said. And this is where it really plays out for heat stress, for example. If you're just shifting the normal distribution towards the upper end, you can say in a previous era, 1951 to 1980, 2.2% of the time you're 2 degrees, the anomaly is 2 above the norm. With in 1981 to 2010, they were 6.5%, and in the last 20 years, 11.5%. So you can see how that affects the frequency of extreme climate events. And I thought I'd just present you a few anecdotes. A lot of you will be aware of the death of dairy cattle in the Shoalhaven region in New South Wales, and you can see how that worked. You had 2 days where the temperature was above 45 degrees daytime temperature, above 50% humidity, and you had a temperature humidity index of 90. Now, those of you who've worked in heat stress, I mean, animals start suffering above about 82. So temperature humidity of 90, and led to 40 dairy cow deaths. This is a more recent one from a farmer that Brendan Cullen and I have been working with in Longreach, who sent through an email recently, and Peter Whipps, one of the local climate champions in that region, has done a lot of good work. But if you just read through that here, in that heat wave we had end of December to January 2014, average daytime temperatures on his farm, he actually recorded up to 55 degrees daytime temperature. Night times didn't get below 25, and he had Bos Indicus cattle and composites just sitting down and dying within sight of water, within sight of feed, and he's never actually seen that on his property before, and he's been there for most of his life. And then just to make it worse, he had 136 millimeters in 5 hours, and basically drowned the rest. So this is what we talk about when we talk about extreme climate events, and we talk about the issues that climate change is presenting us in agriculture. So if we look at rainfall now, that's temperature. Let's look at rainfall. The last 20 years in southeastern Australia has been drier than average. We know that. The April to October rainfall, definitely we know about the rainfall signal from the mid-1970s in Western Australia has been about 200 millimetres down in the coastal region there. But southeastern Australia has been through quite a change as well. If you flip across to the summer rainfall season, you can see there's not much change from the average, possibly even drier than average in southeastern Australia, but wetter up in the northwest of the country. Got to be a little careful about here because this is a rainfall anomaly, and so if you've gone from 1 millimetre to 2 millimetres, well, that's above average. So if you're in the Nullarbor, I wouldn't take much notice of that, but certainly up in the Kimberley, it has been quite a big increase in rainfall, but definitely a drier signal in the south. What we try to do, prefer to do is look at this map. Now, have a careful look at this as I transition it to the next slide, because this is our historic rainfall patterns in Australia. So you can see the summer dominant rainfall in the north, tropical, through the intermediate rainfall down to the temperate winter rainfall regions in the south, and your dark blues, your Mediterranean region. And if we flip to the next map, it shows you what the last 20 years have looked like. And I'll go between the two again for you. And you can basically see that our weather systems are shifting slowly south. In the last 20 years, we've moved our weather bands about 400 kilometres south from where they were. So if you talk to graziers around the Holbrook region, for example, when they bought their property 40 years ago, it was winter dominant rainfall. Now they talk about getting 50% of their rain in summer, 50% in winter, but the 50% they get in summer is not reliable and predictable, and it's subject to high evaporative loss, so it's not quite as useful. So if you were here, for example, you might think, okay, well, we need to adapt our systems to adjust to capture some of that summer rainfall. If you're over here and you're getting Kalgoorlie's weather moving down towards Albany, probably not a great idea. So what we can see, if you look at the long-term rainfall anomaly for southeastern Australia, you can see random variability either side, but since the millennium drought, pretty much everything is below the line. The anomalies have all been negative except for 2 La Nina years. If you take those 2 La Nina years out of the picture, southeastern Australia has lost about 130 millimetres of rain since the beginning of the millennium drought. And in some of our circles, we are saying, well, it's just a matter of time before we actually say the millennium drought never actually ended. It was actually a step change, same as Western Australia. It's just when you're talking to climatologists, they need 30 years worth of data before they actually make any pronouncements about the trend change. So we haven't quite got there yet. But pretty much you can see the picture. 2 La Nina years, the rest below the line. So what I thought I'd present to you is just a few examples of what's actually already happened. This is a colleague of ours, Zvi Hochman, who looked at the wheat industry and mapped the productivity growth of the wheat industry from 1900 to about 2000, showing a steady year-on-year growth of about 1.6% per year. And then from 1990 onwards, showing a distinct change in the trend, a flattening of that trend. We've seen the same thing in the dairy industry, we've seen the same thing in the red meat industry. And in this paper he attributed to a declining growing season rainfall signal and a slow increase in temperature. We published a paper in Agricultural Systems in 2018 where we modelled wheat production across a bunch of sites, across from the subtropics all the way through the temperate zones. And this is the only data-heavy slide, so I apologise for that. But if you just take the scenarios where you've got a baseline case here, you've got an optimistic scenario, you've got a realistic scenario, and you've got a worst-case scenario. So those are the 3 colours. And it's either 2030 or 2070 in the 2 scenarios. And just generally, if you take the yellow graphs, you can see that that's the sort of most likely climate scenario for the wheat industry. And in the subtropics, you can see it's generally, it might be okay because the rainfall signal is not quite as distinct and we're getting this just change in the seasonal distribution. But if you go to the southern regions, all the sites that we have in the southern regions of Australia, even with the average case or the best case scenario, they all start looking a bit grim by the end of the century. If you take the red scenarios, well, they all look worse. So basically in southern Australia, we're going to see an increasing challenge to wheat production, probably less so in the subtropics. What's happened in other industries? Well, some of the work that Snow Barlow supervised with Leanne Webb showed that the grape industry, we're seeing a gradual maturation of grapes earlier in the season by about 8 days per decade advanced towards the summer period. Not surprisingly, things are looking better in Tasmania. The Tasmanian vineyard area has grown by over 500% in the last 20 years. Some of you would be aware of Brown Brothers that have got this narrative that they present on how they took the climate science seriously. They worked out that by 2030 they wouldn't be able to produce Pinot Noir quality in Victoria, but they bought the Guns Plantation land and Devil's Corner brand in Tasmania and have made a lot of money out of that. Early movers are definitely at an advantage here. This is something we worked with Snow Barlow on, mapping the southward movement of the cotton industry. And you're seeing cotton gradually, because of a combination of technology development but also a warming climate, cotton has gradually been moving south. It's also been moving north, actually. But we now have cotton grown in a small area of Victoria for the first time. And you think about the implications of that. Well, cotton can pay about 4 or 5 times what dairy can for water. So it has implications. Quite a change. To our area a bit more, in 2009, Brendan Cullen and I published this paper that predicted what might happen to the pattern of grass growth under various future climate scenarios. And you can see the black line being the base case, 2030 climate and a 2070 climate. So pattern of grass growth changing in Victoria, higher winter growth rates, that makes sense because of warmer winters, but a earlier contraction of the growing season. Well, surprise, surprise, we went and mapped that in the last couple of years and found that what we predicted for 2030 and 2050 has pretty much already happened in the last 20 years. And so one of our PhD students, Richika, has been working on this and showing that there's pretty much a drop in that spring growth, and that's exactly what we predicted. If you go back to that and say there's a drop in spring growth over here, an earlier onset of the spring, it's come out in the 2002 to 2015 period of, for example, at Wagga in this case. And what we've also found is that winter growth rates are steadily increasing, for example, at Ellenbank. So pretty much what we predicted in 2009, we're already seeing in the climate signal, quite consistent with what we had predicted. I wanted to spend just a few moments on soil carbon because a lot of people have been very enthusiastic about soil carbon in future climates and that soil carbon can actually save the day. And some of this work that Rochelle Meyer did in her PhD has had a change to the Victorian government policy on the subject. And I'll explain why in a moment, you'll see. The first study that we did was trying to say, well, what if we had to value soil carbon just for its inherent productivity value? Let's put carbon credits to the side and say, what's the comparison between a low soil carbon soil and a high soil carbon soil just in extra plant available water holding capacity and the production from that and extra nitrogen mineralization potential and the extra productivity? And you can see there the kind of figures we're talking about. So in this particular case, the farmer would have been chasing somewhere between $10 and $14 a hectare of carbon credits, as opposed to the inherent productivity value of something like $150 a hectare of inherent value proposition. And this is trying to sort of set the record straight. Let's not chase carbon credits necessarily. There's a reason why you want high soil carbon in your soils. It's just more productive and more sustainable. Rochelle then went on to look at whether that soil carbon can provide an offset against your greenhouse gas emissions. And that study showed that for the period of transition from low carbon to high carbon, yes, there might be an offset, but the day of reckoning comes because diminishing returns kicks in and soil carbon stabilizes at a new steady state, and you still have the residual methane emissions. But the real study that I wanted to highlight here was we then asked the question, well, what happens if you push this into future climates? what happens to that soil carbon under a drying climate with a rising temperature. And this is the study that Rochelle did at Birchip and Hamilton, where we had positive climate scenarios, negative climate scenarios. So these are all the more realistic climate scenarios below the line. And basically, at a drier location, if you wanted to maintain current soil carbon stocks in a grazing system at Birchip, you would, by 2070, you would need to lighten up the stocking rate by 80 to 95% to maintain current stocks of soil carbon. And if you wanted to maintain current stocks of soil carbon in 2070 at Hamilton, you'd need to lighten up the stocking rate by 40 to 50%. That's a bit sobering, saying that actually there's a big trade-off between productivity and maintaining a resource. Soil carbon isn't necessarily a guaranteed part of a climate strategy. And this has changed the Victorian government policy on the subject to say we will incentivise farmers just to maintain current soil carbon stocks into the future, rather than say we're going to have this as a big plank of our sequestration and removing carbon out of the atmosphere. Then this graph is something I presented at the Royal Society meeting the other night, where we were asked to then take all this information and build it down to what does a map of Victoria look like if we push it into a future climate. So there's a bit of a narrative around this saying, well, we know that inland it's going to be more variable, it's going to be hotter, probably more reliable rainfall towards the coast, a bit milder because of the maritime influence. But what's likely to happen is water, for example, will more likely go to higher value commodities. I've probably got almonds there unfairly because I think someone told me it takes 60,000 litres to produce 1 litre of almond milk. So they're not necessarily the most valuable use of water, but they can pay a bigger price for water. We're already seeing a transition in grape growing. There's a lot more of the southern Italian varieties being explored now to come into northern Victoria because the traditional red grapes can't handle the temperatures anymore, and we're looking for those hotter season varieties. We know cotton's coming to northern Victoria and can probably pay substantially more than dairy can for water. And so we're seeing a transition in the northern dairy industry out of your traditional summer irrigated pastures into more confinement, California-style confinement feeding systems as a way of insulating animals against the extreme conditions, and more judicious use of water on crops to supplement winter irrigation rather than summer irrigation. We've also seen a lot of dairy farmers moving south, moving to Tasmania. Those of you who know some of the dairy farmers, Daryl Hoey was on a prominent farmer from the north and interviewed by ABC saying he's packing up and moving south because can't handle the temperatures anymore. If we go back to the northwest, some of our work on the grains industry has shown there's this gradual movement of the grains industry south, because a lot of these farms, when they bought their farms 40 years ago, would have got 8 successful crops in 10. We probably, if you talk to Ian McClelland of Birchip Cropping Group, he was talking 3 to 4 years in 10 a successful grain crop. So they're moving south. And what will probably move into their place is mixed farming systems, where you're actually hedging your bets between a commodity like wool, where you might get a better price for a finer micron in a dry year, and you can probably feed a failed crop to your sheep. So we've seen a dramatic rise in Australia generally of sheep feedlotting to provide farmers with that strategic option to get dual sources of income. We've also seen a retreat of dairy. I don't know how many of you have driven on the back road from Warrnambool through to Cobram lately. You drive past a whole lot of empty dairies on the way. And we've seen dairy retreat into the high rainfall, reliable rainfall regions of West Gippsland and the back of the Otways. And if you speak to the consultants about the area of Yarram through to Orbost, 30 years, 40 years ago, that was considered prime dairy country. It's now considered marginal dairy country. So big change to a rain shadow that seems to have emerged in this region. Some of the work Rebecca Derbyshire did showed that there's an increasing challenge to a winter chilling requirement for your stone and pome fruits in central Victoria. Some of the areas around the Goulburn Valley no longer get the winter chilling that they need for the stone and pome fruits to set seeds. So we've seen a move of those to Tasmania. And then in eastern Victoria, there's a change, a subtle change coming in with that more opportunistic summer rainfall and a slow shift to more summer active pastures in northeast Victoria, starting to look at some of the native Themida pastures to pick up some of that summer rain. In eastern Victoria, starting to look more at Kikuyu pastures to pick up that summer activity. So there's the big picture. I wanted to shift the narrative now to probably more the mitigation side of the equation, but more to explain what we see happening in the international arena and how that could affect agriculture. So we know the Paris Agreement has set a goal of a temperature target of 1.5 and 2 degrees centigrade. But one of the important things in the Paris Agreement was for the first time it set a target of carbon neutral production by 2050. And this often gets missed in the drive for the temperature change, but what we're seeing is that a number of businesses and governments are actually trying to comply and align themselves with the Paris 2050 carbon neutral. Prior to that, there wasn't much discussion in agriculture about carbon neutral agricultural production, but we're seeing quite a substantial shift now. Then there was this report, which was the Farm Animal Investment Risk and Return, which is a report to the London Stock Exchange to advise investors of the risk of investment in agricultural production based on their exposure to climate change. And this is the naughty scale. So you go from the good end of the scale down to the naughty end of the scale, and you can see that basically we're not quite sure why Fonterra ended up on that side of the scale, but if you read their sustainability statement, they got a lot of fluffy words in there that say good things, and so they got up on the left-hand side. But within about a week of this being published, I got a phone call from AACO saying, can you do a carbon audit on our property? How do we do this? How do we set a pathway to carbon neutrality? What do we have to do? Because they're a publicly listed company, and the London Stock Exchange, their investors are being told, beware, this is a company that's very exposed to policy change. So that's had quite an impact on the industries. And then I used to have 3 of these slides where I went through all the sustainability statements by multinational food companies. And up until a few weeks ago, this slide was all full of emissions intensity targets that they'd set. So emissions per unit of product, which allows you still to increase production and business as usual, really, just efficiency metric. About 2 weeks ago, I went back through all those sustainability statements of all these companies, and lo and behold, they've all switched. They've all gone to absolute emission reduction targets in line with the Paris Agreement. And so you've got a cascade effect here where you've got Unilever that is setting a target effectively to be carbon neutral by 2050 in line with the Paris Agreement. And you've got Fonterra who then says, well, we can't supply to Unilever in the future unless we comply with their sustainability statements. So Fonterra switched their statement a few weeks afterwards to be carbon neutral growth to 2030 and aiming for carbon neutrality by 2050. And you can see the cascade then on to the dairy farmers of New Zealand, where that's Fonterra New Zealand that made that statement. And so suddenly the supply chain is under pressure to be carbon neutral. Olam, Wilmar, and you can keep going on all these companies responding to what they see as a direction change. Now, one thing that came home to me is the Financial Times had this statement in it recently that they said of the largest 100 economies in the world, 69 are companies, not countries. And I think we're living in a world where things are changing substantially, and that government policy is actually becoming less important than company policy. And what are these companies responding to? They're responding to you as the shareholder, or the perception of your changing preference. So actually it's an empowering thing rather than a disempowering, because it means that your purchasing, your consumer preference can actually have a material impact. And while we spend most of our time expecting government to make policy about climate change, actually where most of the move could come from is from these types of companies that are actually setting a pace change. I'll explain that. I was sitting with a bunch of policymakers in a boardroom in Edmonton, in Alberta, talking about their climate policy, and they were having a similar complaint about lack of government action to what we talk about in Australia. And one of the policymakers put this up on the board and said, this is our thinking. Government usually operates on the left-hand side of the normal distribution, trying to stop the laggards from being worse, trying to come in with policies to curb nitrate pollution, nitrate leaching for those who apply too much fertilizer. And we expect government to be operating here, when in actual fact most of the time government is reactive, operating on this side. What we're now seeing is the multinational companies wanting to lead the way, show leadership, show market advantage, and they're sitting on this side. And actually, maybe we've been expecting the wrong people to make the wrong decisions and actually not seeing that this is where the action could actually be. Partnerships with industry. Then, of course, there's a whole lot of other pressures coming on the livestock industries or the agriculture industries generally. The social license to operate. This is the Australian red meat plan from a few years back. I was involved in that plan, and for the first time, we actually considered not just the benefits above the line, the productivity benefits of investment in industry growth. For example, that's the investment in markets and diversification. This is investment in productivity and the return to the industry. For the first time, we thought, well, what if we get it wrong? What is the downside risk of actually getting consumer and community support if we lose that? And lo and behold, that became far bigger below the line than investments on productivity growth above the line. And the Canadian Red Meat Plan says exactly the same thing. If we get it wrong, take, for example, sheep live export to the Middle East, you get that wrong, you lose your social license to operate. So we're also seeing rising vegetarianism, synthetic meat and milk, which I think is producing a challenge. But then there are these trends where we see the developed world, meat consumption in the developed world not actually increasing that much. We know that because of rising vegetarianism, because of diversification of diets. But we've got the world rising middle class actually requiring substantially more animal-based protein in their diet. What's not on this graph is what's the population in there and what's the population in there. This trend here, by 2050, we're going to be adding about 5 billion people to that population graph. So the demand for red meat will continue to increase. This was a bit of a sobering one, is seeing a company like Danone, one of the world's larger dairy companies, spend, $12.5 billion buying up all the alternative milk brands, the silk brands of milk. So that's almond milk, coconut milk, cashew milk, soy milk, I think rice milk was in there as well. Recognizing that this is a fast-growing market segment and not wanting to be left out of the picture and wanting to diversify. Now, a lot of people said, well, this is just about, business strategy and diversifying, until you read what they were saying on their website about the reason why they had bought into the silk brands. And they're using words like accelerate towards sustainable and profitable growth. What they're saying in that is implied that traditional dairy production might not be as sustainable as nut milk, until you work out almonds take 60,000 litres for 1 litre of almonds, but we won't go there. And healthier and more sustainable eating. So they're implying that these are more sustainable options that people can transition to, and just recognizing that it's almost like Shell announcing they're no longer a fossil fuel oil company, that they're an energy company. So a bit of rebranding going on there. But what started happening in response to the Paris Agreement is this change where we've heard Meat and Livestock Australia come out and say red meat production in Australia can be carbon neutral by 2030, given the right R&D and policy settings. And that was Richard Norton, the Chief Executive Officer. And then he resigned and moved on. But we won't go there. And the state of Mato Grosso do Sul have launched their carbon neutral initiative. So as a state in Brazil, they plan to be carbon neutral. And that does very much include the livestock industries. And as a result, you've seen this carbon neutral Brazilian beef brand emerge. Now, we were recently with the team in Embrapa that developed the carbon neutral beef brand, and, well, it's not exactly carbon neutral. It doesn't include the breeder herd, and it only includes 2/3 of the steers for the last portion of their life. But it didn't stop them going down the route of marketing an advantage of selling carbon neutral beef into the European Union market. We've seen the New Zealand government propose the zero carbon bill, which clearly includes agriculture, and the only separation that's going on in New Zealand, and it's an interesting debate to watch, is how they've separated out the short-lived climate polluting gases like methane from the long-lived gases. So the long-lived gases have to go to zero by 2050, but they're proposing a different target for methane because recognizing it's only in the atmosphere for about 14 years, but has quite a dramatic warming change between its first year in the environment compared to its last. And then we've seen the IPCC come out and say that diet choice is part of the solution, which has had quite an impact as well. Now, just in the last few weeks, we've been able to do a bit of a roundup of what's changed in the red meat industry in Australia in the last probably 18 months. You've had a number of companies start responding to this MLA target of carbon neutral 2030. So you've had Arcadian Organic Meat, 100% carbon neutral. NAPCO, one of the bigger corporates in Australia, probably the second or third largest corporate, have launched the Five Founders Beef brand, which is a carbon neutral brand, and they're only achieving that by buying carbon offsets. So they're not actually reducing methane or anything on the actual farm. Flinders Meat as well, carbon neutral wholesale. So you'll see these brands emerging in the supermarkets already. And just our group alone, because we've done some carbon audits on a number of properties and published some of those case studies, just in the last few months, I've had 5 of the large corporates, AACO, NAPCO, approach us as a group and say, how do we do this? What do we do? How do we move towards carbon neutrality? So instead of going out and actually doing the carbon audits on these properties, we're working with MLA on a standard accounting tool that allow those corporates to do their own carbon audits. So, we could spend our lives doing carbon audits. That's not the business we're in. Let's rather go to the other end and come up with a standing accounting construct that has scientific rigor that then can't be undermined like the Brazilian carbon neutral beef story. And then more recently, I had an approach by the head of energy and sustainability. He came to visit me saying, we want to offer customers that come to Coles, by next year this time, they want to offer you as a customer, on your weekly groceries, you pay 70 cents as a carbon offset and you can walk away guilt-free with carbon neutral groceries. And where that came from was because one of the major suppliers of Coles prime lamb in Victoria is Jigsaw Farms. And we did a carbon neutral audit on Jigsaw Farms, published that as a case study, and then Coles got the idea, well, actually, if we can get our lamb carbon neutral, well, we can do everything else carbon neutral. So I'll show you those. So a lot of what's going on is underpinned by a number of studies that we did. This was the whole farm systems analysis of mitigation options project that we ran about 3 years ago. And it was a very productive project. If you can look at that, the number of references over 3 years is pretty impressive. But what we did is we went through all the options that graziers have or livestock producers have around emissions intensity per product, management effects, what you could do around fertility, longevity, genotype, pastures, earlier mating, nitrogen use efficiency, feeding different supplements from lipids, nitrates, and the miracle new product called 3-NOP that in a feedlot study in Canada has just actually shown a 75% reduction in methane from beef steers in that feedlot. So fairly impressive. Legumes, and from these papers that we published ended up underpinning a number of carbon offset methods that the livestock industry now have access to. So we informed the beef herd methodology by all of this work here and the legumes work. The nitrates methodology, there's a bit of an irony there. We published 2 papers that said the method would never be adopted. They went ahead and did it based on our papers, and it's never been adopted. The dairy supplements paper and the nitrogen fertilizer methodology all come from those studies. But the 2 that seem to have had the biggest traction is these carbon neutral studies we did. So Natalie Brown in our group, we started on a low stock wool property up near Yass. And this was John Ive that took on a degraded property that had a lot of gully erosion. And part of the project was to produce the finest wool that he could. So he is supposedly the finest wool producer in Australia. So very low stocked, but a lot of land restoration, a lot of gully erosion that was being rebuilt, a lot of trees being brought back into the landscape. And so we were able to do a carbon balance that showed there were the trees from the time he moved onto the property. There was the soil carbon restoration, there was the soil carbon in the slopes and the pastures, and those were the greenhouse gas emissions. So the figure below the line, not a big impact because of a low stocking rate, because it's 5 DSCs to the hectare. So on the balance, the carbon was very positive on the property. We then thought, well, that was a very low stock property with a deliberate land restoration strategy. What if we went to the highest stock property we could find in Victoria, which was Mark Whitten's farm out at Hamilton. And in this particular farm, he's now got 20% of the farm under trees. A lot of the strategy is around salinity control, around biodiversity, and you can see the trees in this carbon audit. We didn't account for too much in the soils because it was long-term permanent pasture, but because of the high stocking rate, there's quite a substantial amount of greenhouse gas emissions that keep accumulating as a result. So the carbon balance was pretty impressive, close to zero, but not quite zero. on a cumulative basis. Of course, what's being asked for in the current carbon neutral discussion is not that cumulative carbon picture, it's a year-by-year balance. So when we take Mark's property and say, let's put it on a year-by-year balance and say, there's the livestock, which should be a minus sign, the trees, the soil, which should be plus signs, and the net balance being negative. There was a period between 2010 and 2017 where that balance was positive because there was enough carbon being stored in the soil and the trees to completely offset the livestock emissions. And so Mark accepted that the law of diminishing returns would eventually kick in, and the trees would mature and they'd no longer be locking up new carbon. The soil would mature and wouldn't be locking up new carbon. And so the next strategy here is then to take on some of these mitigation options in his sheep feedlot to start feeding Grape Mark and some of these other products to pull down the methane column, which is essentially that there. So just to summarize, I think, and this is my view, and it seems to be an emerging trend, that carbon neutral production will become an expectation, not just something that a few of us will do. We've shown that livestock farms can be carbon neutral. It will initially take a substantial amount of carbon offsetting in trees, and that has only a limited timeline. We're also seeing an emerging policy change to challenge the right just to offset your greenhouse gas emissions, saying, well, methane is different to carbon stored in trees, that's CO2 and this is methane, or nitrous oxide is fundamentally different to CO2 stored in vegetation. So actually the idea of offsetting is now being challenged. And it means that we have to actually do something about the methane itself. So in the near future, I reckon we'll see a lot more planting of trees on farms. We'll see more recognition of carbon in the landscape, the need for that change, driven more by the economics of shade and shelter and animal welfare, because the carbon itself is probably not going to pay for it. But actually a small amount of lamb survival, a small amount of shade and shelter will have a far bigger impact. And definitely move towards more benign sources of nitrogen, more soil organic carbon where possible. But at the end of the day, we also need some way of dramatically reducing methane from animals. So, thank you.
Thank you, Richard, for a very enlightening presentation. So it's now open, the debate's now open up, or it's now open for some questions from the audience.
Yeah, Richard, I'm interested in your livestock and rates and seeing how that works out from a carbon neutral point of view. But how do you see growers embracing that if they're running, if at 5 DSCs they're not making money on their properties because they're not selling enough stuff? How's that going to play out?
Yeah, look, I think there's a transition going on, so that's why we did Mark's farm as well, and part of the paper we published on Mark's farm had a whole lot of scenarios of tree proportions by rainfall zone, by stocking rate. So we'd actually look at where that was for different regions, and moving from 5 to 25 DSC. Quite clearly, there's a stocking rate issue in there that, I guess what it tells us is trees can only go part of the way. And that's why I say trees are probably more a solution around shade and shelter, and then look at the co-benefit of carbon rather than actually drive it by carbon. But what it does mean is that in the next few years we need to come up with strategies that those farmers can take on. For example, Mark Whitten's farm, he knows already he's got a few vineyards up the road that have a disposal problem with their Grape Mark. We've done the work on, we published a few papers on Grape Mark having about a 20% reduction in methane. So he could bring in the Grape Mark and put it into the feedlot as one of the feeds he's feeding, buy it in at, I think Grape Mark's probably, $140 a tonne in a non-drought period. So actually very cost effective to feed, and have quite a big impact on the methane side of the equation. That makes the tree offsetting target a lot easier to achieve at a high stocking rate. I don't know if that answers the question. Okay.
Obviously this is my area, but is it possible without having the trees to offset the carbon, given that it's like diminishing returns from those trees, is it possible to have a scenario where without that, without relying on that, you can be carbon neutral?
Be very difficult. So we've just worked with the Victorian government and Dairy Australia on an analysis of if the Victorian dairy industry tomorrow had to reduce their emissions, what proportion could they do with current technology? Stuff that we've evaluated. And we came up with a figure of 50%. So dairy tomorrow, if the policy conditions were there, the dairy industry could cut its emissions by 50% tomorrow without using offsets. That's pretty impressive compared to where we were 10 years ago. Now, that's not cost effective right now. So you would need a carbon price to drive it. But, you know, the conversation we were having 10 years ago where we probably could have done 10% just by tinkering at the edges compared to now 50%. You know, and then the feedlot in Canada that gives us hope that you can cut methane by 75%. We're on the way to getting there, I think.
Yeah, Richard, thanks. Terrific talk. When I've looked at it, Australia's agriculture, we're a high-cost carbon sequesterer because the agriculture output we give up is more valuable than the carbon. And then as climate gets worse, that high cost will drop, but so will the amount we can sequester.
Yep.
You know, we're only good at sequestering where we're good at growing stuff, where it rains. And the soil carbon one's pretty dodgy because of the nitrogen story, so there's a few limits there.
Yep.
But the focus on greenhouse gas carbon neutrality, it's a very crude technical solution, and it's something, but it's a very inefficient way, and it's not going to be the solution. It's going to be change behaviour driven by economics, and so none of what you said today, which is all, you know, encouraging to see firms responding to, say, consumer, but none of this carbon neutrality as a technical regulated solution is going to replace having a price and a cost on carbon. So not every producer needs to be carbon neutral if you've got everything priced properly.
Yes, no, I fully agree. The driver, I mean, the reason why dairy could reduce its emissions by 50% but are not going to do it, well, there's no price on that. There's no price on carbon. The Emissions Reduction Fund, we know, I mean, we developed a method for dietary oils for dairy cattle. We knew it would never be taken up. Actually, ironically, Fonterra was part of that development, and they sat there supporting the development because they could put it in their sustainability statement. They knew it would never be taken up because it's just not cost effective. As you know, if you've got an oil and a vegetable oil of some sort, everyone else wants that now as well. So the dairy farmer at the end of the line is probably the last person that's going to buy that oil. But a price on carbon might actually make that oil on parity with grain, for example, as an energy source. And then you start seeing change, I think.
A comment and a question. It seems to me that agriculture is sort of pilloried to an inordinate extent in comparison to sort of some other issues. I mean, the human population has quadrupled since the 1960s. And in this argument, nobody ever takes that into account. So that's my comment. My question is around the issue of using trees for sequestration, and I was quite impressed with the way that you saw the diminishing returns. In New Zealand, I understand that the riparian planting along rivers has switched from using trees to using pampas-style grasses so that they can sequester product into those plants, they can be slashed, they can regenerate, and you don't have this law of diminishing returns. Have you seen anything of that type?
I haven't come across that. I mean, grasslands will sequester carbon at a faster rate than trees, but not over a 100-year term.
Pampas stuff.
Pampas, yeah, the stuff that we consider a noxious weed.
Yeah,
look, I don't know if that would store more carbon in the long term. I mean, the long term, if you're looking at 100-year carbon storage in the landscape, trees are always going to beat grasses. Grasses are quick to get carbon up in the root zone. So in the first 20 years, you'll get more carbon in the stored out of grasses. but in a sort of 100-year time horizon, trees are always going to have more underground carbon and above ground carbon. So I'm not sure what, it might be something else driving that strategy in New Zealand, more about stream bank erosion.
Well, no, it was just that you know the plants would sequester a large amount of nutrient and runoff and what have you, but then you can slash them and they'll regrow. So
Yeah, I reckon nutrient absorption, they'd probably be better. Like runoff from the neighbouring paddocks going through that grassland and the grassland able to absorb the nutrients. Trees wouldn't be as good at doing that. I can see that working, yeah.
Is there a question?
I just wanted to know how soil carbon credits work with bushfires. So what happens when you do have a bushfire going through an area? What happens to your carbon credits then?
Yeah, so if you've sold your carbon credits in a bush block, in a forestry plantation, and you've got to remember someone else probably sitting in a boardroom in Melbourne owns those carbon credits, and you have a bushfire going through, you don't have to pay the carbon credits back because it's a natural disturbance, so it's built into the methodology. Okay. But you do have to show that you have a structured plan to restore that asset over time. And you can't claim any carbon credits until you've restored the asset back to the point it was before the bushfire. After that, if you store more carbon, you can claim more carbon credits. So there's a clause in the offset agreement that compels you to maintain the carbon asset and to restore the carbon asset if it's lost. If you fell it deliberately, like if it's an anthropogenic act to actually fell the forest, you pay 100% back. So yeah, you can't harvest it.
So, Richard, I saw some data the other day that said that 28% of the world's cattle are in India. Now, many of those cattle are non-productive, they're just like teenage boys, they hang around on the corners, and they're contributing to the greenhouse gas emissions.
Yeah.
I mean, what's the global feeling about handling? That's a very sensitive issue because these cattle are, for religious purposes, untouchable. So,
It's a good point because we've got the same issue. If you think of rural areas in Africa, for example, where people might actually be largely vegetarian, and the only way they can maintain a vegetarian lifestyle is actually having cattle to produce the manure in the corral at night to provide the nutrients to grow the crop, and the cattle to actually pull the plough to plough the field. So actually to be a crop producer in Africa, you need livestock generally. So it's a similar issue. And I guess that's one of the reasons so one of the organisations I'm part of is the Global Research Alliance on Agricultural Greenhouse Gases. And one of the strategies we've got in there is, yes, the 3NOP and the red seaweed and all the methods that are coming out to reduce methane are fine, but what we need for the developing world is low-cost, sustainable, repeatable, inheritable strategies to reduce methane. We haven't got there yet. And that's because if you want to have any impact on the developing world, well, you're going to have to go down that track. Having said that, one of the things we are doing, as you're probably aware, is we've got 2 PhD students in Nairobi with ILRI that are looking at tropical legumes, bringing in desmanthus, lotus, desmodium, just as a more sustainable improvement in animal production, but also the tannins having an effect on methane.
Any more questions? If not, I'd like to thank you, Richard, because I think what you've done here today is done exactly what we wanted in the Dean's Lecture series. You presented some high-level science, but you presented it in a manner that the wider community can capture and make sense of. So I think this is exactly the sort of talk that we like in this series. So
Thank you.
Thank you all once again for joining.